All right. So now we're talking about finding the equations of tangents and normals. So let's say we have this curve right here, right? And what the equation of the tangent is let's say we have some point right here, P, with coordinates xp and yp. So the tangent line is that line that passes through this single point on the curve. And so this point is known as the point of tangency with the curve. And then the normal is a line that is perpendicular to the tangent that passes through the point of tangency P. So in order to find the gradient of the tangent line, we need to find the gradient at this point, which is by finding dy by dx and plug in the x and the y value at point P. Then the equation of the line is given by y minus yp, and it's equal to the gradient of the tangent into x minus xp. Then to find the equation of the normal is perpendicular to the tangent, and so the product of the gradient of the normal and the tangent is -1, and so the gradient of the normal will be given by -1 over the gradient of the tangent. We can then use this formula to find the equation of the tangent line. Equation of the normal line, that is. All right. So let's look at an example. So find the equation of the tangent and the normal of the curve y equal to x squared ln x plus 1 when x equal 1. So to find the equation of the tangent of this curve, what we would then do is say, okay, y is equal to ln x squared ln x plus 1 when x is equal to 1. So first, we find dy by dx. So dy by dx is going to be equal to, dy by dx is going to be, we differentiate this, we get dy by dx is equal to, keep the first, x squared times the differential of the second. When you differentiate ln x plus 1, we get 1 over x plus 1 plus, keep the second, so we keep the second, which is ln x plus 1 times the differential of the first. Differential of the first is 2x. And so what we end up getting is that dy by dx is equal to x squared over x plus 1 plus 2x ln x plus 1. That's dy by dx. Now remember, we need dy by dx when x is equal to 1. So when x is equal to 1, we're able to get the gradient of the tangent. So when x equal 1, this is going to give us the gradient of the tangent. When x equal 1, the gradient of the tangent is equal to, we'll plug in 1 into this right here. So we're getting 1 over 1 plus 1, which is 1 squared plus 1 plus 1, which is 2, plus 2 times 1, as x is 1 right here, times ln 1 plus 1. And ln 1 plus 1 is ln 2, right? And so the gradient of the tangent works out to be a half plus, this looks like 2 times 1 is 2. I can bring up the power to write it as a half plus ln 2 squared. ln 2 squared. So that's the gradient of the tangent. And so the equation of the tangent, so the equation of the tangent is y minus yp, which is your y value at the point. Now from this question, they did not give us the y value at the point. So look how we're going to find the y value at the point. When x equal 1, right, we can plug x equal 1 into the original equation to get what y is. So plug x being equal to 1 into this equation to get y is going to be 1 squared times ln 1 plus 1. And so y is actually just equal to ln 2. Y is equal to ln 2. So the equation of the tangent is then y minus the y value at the point, which is ln 2. Y minus ln 2 is equal to the gradient of the tangent. The gradient of the tangent is a half plus ln 2 squared, which is ln 4. A half plus ln 4 into x minus the x value at the point, which is x minus the x value at the point is 1. And that would be the equation of the tangent. Now, how do we find the equation of the normal? The equation of the normal, of course, you can simplify to make this equation written y in terms of x, but for our purposes, we're just going to leave it like this. We're leaving it in exact form. So the equation of the normal would be given by y minus yp, which is y minus ln 2, and it's equal to the gradient of the normal. Now this is the gradient of the tangent, and so the gradient of the normal, remember the gradient of the normal is minus 1 over the gradient of the tangent. The gradient of the normal is minus 1 over the gradient of the tangent. And so whatever is a half plus ln 4, we're going to put minus 1 over a half plus ln 4. Of course, you would have your calculators to simplify this. I have no calculator, so we're just leaving it exact. So it's minus 1 over a half plus ln 4 into x minus 1. And that would be the equation of the normal. You could go ahead to make y the subject to simplify it. Alright? Easy question. Alright, so this question says find the equation of the tangent given by the curve xy squared minus 3x squared y equal to 4x at the point 1, 4. So the first thing we need to do is find dy by dx. We need to find dy by dx. So how we're going to find dy by dx? What we're going to do is right here where it says xy squared, we're going to differentiate this as a product. So step 1, we need to differentiate the entire curve d by dx of xy squared minus 3x squared y equal to 4x. So we need to find d by dx of this. So to find d by dx of this now, what we do is we keep the first, xy squared is a product, so we keep the first times the differential of the second. To differentiate y squared, when we differentiate y squared using implicit differentiation, we get 2y times dy by dx. dy by dx, I'm going to write it as y prime, plus keep the second, which is y squared, times the differential of the first, and the differential of x is 1. Right? Then minus, now I'm going to put like a bracket right here, right? Because I'm looking at 3x squared y, right? So I'm going to differentiate 3x squared y now. And I just want to keep the negative on the outside. So 3x squared y, 3x squared is like your u, and your y is like your v. So using product rule again, it is keeping the first. So keep the first 3x squared times the derivative of the second, and the derivative of y is y prime, plus we keep our second, which is y, times the derivative of our first. And when we differentiate 3x squared, what we're getting is 6x. Right? Close up that bracket. And that's equal to, when you differentiate 4x, we're getting 4. So that's equal to 4. So now all we need to do is make dy by dx the subject and find the gradient at the point 1, 4. So what we're going to do then is this having dy by dx, this part of dy by dx, and this of dy by dx. So everything else we're going to bring to the other side. So let's do that. So we're going to keep, this becomes 2xy times our y prime times our y prime. Now, this we're going to bring over the other side, so don't worry about that. Minus 3x squared y prime, 3x squared y prime. And after we minus x squared y prime, what we're going to do now is we're going to bring over, so that becomes equal to 4 minus y squared minus 6xy. Alright, so this y squared, we brought it over here, and this minus 6xy, we brought it over here. And so this is what we have now. And so now we can factorize out y prime, and so what we get now is, we factor out y prime to get 2xy minus 3x squared and that's then going to be equal to 4 minus y squared minus 6xy. And then only thing left back to do now is make dy by dx the subject. So we're going to divide through by 2xy, 3x squared. And so finally what we're getting then is dy by dx is equal to, dy by dx is equal to 4 minus y squared minus 6 times x times y divided by, this becomes 2xy minus 3x squared. Nice. So the question wants the equation of the tangent. So to find the equation of the tangent, first we need to find the gradient of the tangent. And so at 1, 4, what we can then say is that the gradient of the tangent is going to be equal to, we plug in 1, 4 into this equation right here for dy by dx. So it becomes 4 minus y squared, which is 4 minus 4 squared, because y is 4, minus 6 times your x value, which is 1, times your y value, which is 4, divided by 2 times 1 times 4 minus 3 times, that x value looks like 1, so it's minus 3 times 1 squared. And so what we're getting is that the gradient of the tangent works out to be 4 minus 4 squared, which is 16, minus 6 times 1 times 4. 4 times 1 is 4, 4 times 6, 4 times 6 is 24. That's being divided by 2 times 4 is 8, minus 3 times 1 is just 3. And so what we're getting is 4 minus 16 is negative 12. Negative 12 minus 24 is what? Negative 36. And so we're getting negative 36 over 8 minus 3 is 5. So just to check again, just to make sure that we didn't make any mistake, y is 4. And so 4 times 1 times 6 is minus 24. And 4 minus 4 squared is 4 minus 16. And minus 16 and minus 24, that's minus 40 plus 4, that's negative 36, which is fine. 4 times 2 in D is 8. 8 minus 3 is 5. So you always just want to confirm that that really and truly is the gradient of the tangent. Alright? So we always have to confirm. Okay, right here. So right here, because usually These questions work out a little bit smoother, and I've just picked it up right here. So right here, when we expanded, it would have gotten minus 6xy. When we bring it over, it would become plus 6xy, right? Plus 6xy. So we have to always keep our eyes sharp for those sort of stuff. They should have been plus 6xy, should have been plus 6xy, they should have been plus. Alright, and if that is plus, this is plus. So this works out to be 28 minus 16. That's what that should be now, because this becomes plus 24. Alright? Can't make those sort of mistakes. So this is plus 24, that's 28, and 28 minus 16 is 12. So let's fix that. 28 minus 16 is 12. 28 minus 16 is 12. So the gradient of the tangent is 12 over 5. So since we found that the gradient of the tangent is 12 over 5, now we can find the equation of the tangent. And the equation of the tangent is given by y minus yp, and that yp is 4, so it's y minus 4 is equal to the gradient of the tangent, which is 12 over 5 into x minus 1. That would be the equation of the tangent. So this is now the equation of the tangent. So I write tan right here to represent the equation of the tangent. Now to find the equation of the normal, it would just be y minus yp is equal to, well, if this is the gradient of the tangent, then the gradient of the normal is going to be, remember, the gradient of the normal is equal to minus 1 over the gradient of the tangent. And so the gradient of the normal is just going to be minus 5 over 12 into x minus 1. And that would give us the equation of the normal. So NORM stands for norm, which is normal. Easy, soft.